Hi everyone. In this video, we are going to learn the merge sort algorithm. We'll walk through an example, discuss its efficiency, and write a code to implement it. We'll be using ascending order for sorting. Let's get started. Merge sort is a divide and conquer sorting algorithm. It works in two main steps. First, it divides the main array into smaller sub-arrays until each sub-array contains only one element. Then, these sub-arrays are merged together in a sorted order, step by step, until the entire array is sorted. Let's start with an illustration. Given an unsorted array of length 5. The first step in merge sort is to divide this original array into smaller sub-arrays until each sub-array has only one element. Here's how we divide it step by step. The length of this original array is odd, so we divide it unevenly. The left subarray gets the first two elements and the right subarray gets the remaining three. Focus on this left subarray. It has two elements, so split it further. With this, the left portion is completely divided into its simplest form. Therefore, move to the right subarray. It has three elements, so divide it further. This left subarray here is having only one element, so no further action is required. The right subarray has two elements, so we need to divide it further. At this point, we have completed the step 1. That is, the original array is divided into individual subarrays having one element each. Now, let's move on to the second step of the merge sort, that is, merging the subarrays in a sorted order. Starting with the left portion, here we have only two subarrays having values 9 and 6 respectively. Please remember, we are going to sort this list in an ascending order. So compare 9 with 6. Since 6 is smaller than 9, it will appear first in our merge list. There are no more elements on the left hand side. So move to the right side. Here we have altogether 3 subarrays having values 7, 8 and 7. For the 7 in left, first we need to compute the merge result of the rightmost portion. So let's compare 8 and 7. So let's compare 8 with 7 in black. Since 7 is smaller than 8, it will appear first and then 8. And then the result of the rightmost portion needs to be merged with 7 in red. Compare the two. 7 in red is less than or equal to 7 in black. So 7 in red will come first. And then the remaining items needs to be appended to the list. No more comparisons required because they are already sorted. And finally, the result of the left portion and the resultant subarray of the right portion needs to be merged together in a sorted order. Let's first compare 6 with 7 in red. 6 is smaller, so it will come first. Then compare 9 with 7 in red. 7 in red is smaller, so it will be chosen. Then compare 9 with 7 in black. 7 is smaller, so it will occupy the third position. Then compare 9 with 8. 8 is smaller, so it will occupy the fourth position. Then compare 9. There are no more elements which are left, so 9 will be appended to the list as it is. And now you can see the array is in a sorted order. Let's now implement the merge sort. It has two main parts. Step 1. Dividing the array into subarrays until each subarray contain only one element. And step 2. merging the subarrays in sorted order. Let's start with step 1, dividing the array. First, let me explain how the mid index is calculated to split the array. At each level, find the length of the array and divide it by 2. Take only the integer value. Example, for an array of length 5, when you divide it by 2, the result is 2.5. So we take 2. Use this as a midpoint to split the array. The left subarray will range from index 0 to mid minus 1, and the right subarray will start at mid and go to the last index of the input array. Repeat this process for every subarray until each subarray has only one element. Since this is a repetitive process with modified inputs, we'll use recursion to solve it efficiently. I have already created a detailed video on recursion, and the link is in the description. Feel free to check it out for a deeper understanding of how recursion works. We'll create a function called merge sort divide. Its main job is to break down the input array into subarrays. Let's first define a base case or stopping condition for a recursion. If the array has only one element, it's already sorted. In such case, the function simply returns the array as it is. Then comes the winding phase. We calculate the midpoint to split the array into two halves. Left subarray, all element from start up to mid minus 1, and right subarray with all elements from mid to the end. Each of the subarrays is passed to merge sort divide recursively. Then comes the unwinding phase. Once we have reached the base case, that is subarrays with one element, we start returning from the recursive calls. The temporary list is used to combine the left and right subarrays at each level. Here is an example of temporary array obtained after combining the highlighted left and right subarrays. The merge function is called to sort and combine the elements from temporary array. At this point, we have completed step 1, that is, dividing the array into smaller subarrays. We have also written code to prepare these subarrays in a temporary array, setting the stage for the next step, which is merging them in sorted order. In this section, we'll learn how to merge two sorted subarrays. In the previous section, we combined the left and right sorted subarrays into a temporary array. This temporary array now becomes the input to the merge function. Let's get started with step 1. We'll identify the midpoint and the required indexes. Low is set to 0, which is the starting index of the array. In this example, the length of the temporary array is 5. The midpoint is calculated as 5 divided by 2. The result is 2.5, but we'll only consider the integer part, which is 2. This gives us the left subarray ranging from index 0 to 1 and the right subarray ranging from index 2 to 4. We'll use these ranges to compare the elements and merge the arrays step by step. Here comes the first iteration. Low 1 points to the start of the left subarray, which is 0, and low 2 points to the start of the right subarray, that is 2. Compare the elements at low 1 and low 2. 6. The smaller value is added to the result array, and low 1 is incremented to 1. Then comes the second iteration. Low 1 is now at 1 and low 2 is still at 2. Compare the elements 9 and 7. Among the two, 7 is the smaller value and it is from the right subarray. It is now added to the result array and low 2 is incremented to 3. Third iteration. Low 1 is still at 1 and low 2 is now at 3. Compare the elements. 7 is smaller and it is added to the result array again, and low 2 is incremented to 4. Fourth iteration. Low 1 is at 1 and low 2 is at 4. Compare the elements 9 and 8. 8 from the right subarray is smaller and it is added to the result array, and low 2 is incremented to 5. At this point, all elements from the right subarray have been added to the result array. What remains is the last element from the left subarray, which is 9. Since the left and right subarrays are already sorted internally, any remaining elements can be directly added to the result array. So, we take 9 and append it to the result array. This is how we handle the remaining elements. Finally, we have now merged all elements from both subarrays. The original array is sorted in ascending order. Let's implement the code to merge two sorted subarrays. We'll create a function called merge that takes an array as input. Step 1 is to initialize indices and auxiliary array. Low 1 for the left subarray, low 2 for the right subarray, and the mate to separate them. Create an auxiliary array to store the merged elements or the results. Step 2. Compare and merge elements from both subarrays. Use a while loop to iterate over both subarrays as long as neither is exhausted. The loop condition low 1 less than mid and low 2 less than high ensures that we process elements from both subarrays until one of them is fully traversed. Step 3. Append remaining elements. If any elements remain in either subarray after the loop, append them directly to the auxiliary array. Finally, return the merged auxiliary array, which now contains all elements sorted in ascending order. Let's evaluate the time complexity of the merge sort. The first step in merge sort is to repeatedly divide the array into smaller subsets until each subset contains only one element. At level 1, there is only one subset, which is the original array. At level 2, the array is divided into two subsets. At level 3, it is divided further into four subsets, and so on. This forms a sequence 1, 2, 4, 8, and so on, which corresponds to powers of 2, which is equivalent to 2 raised to 0, 2 raised to 1, 2 raised to 2, and so on. This sequence can be generalized as log n to the base 2. Once the array is divided, the next step is to merge the subsets in sorted order. At each level, we merge two sorted subarrays. Let's say their lengths are n1 and n2. Merging requires n1 plus n2 comparisons, which adds up to big of n operations for all elements at each level. The process involves log n to the base 2 levels, and at each level the merging step takes big of n time. Combining this, the total time complexity is equal to total subsets into runtime of merge, which is equal to big of n log n. The space complexity of merge sort is big of n because it requires an additional auxiliary or temporary array to store the merge results. For n element, an extra array of length n is needed, making the space complexity linear. Merge sort is also a stable sorting algorithm, meaning it preserves the relative order of elements with equal values. For example, in our case, there were two sevens. In the unsorted array, the red 7 appeared before the black 7. After sorting, the red 7 still appears before the black 7, maintaining their relative order. And with that, we come to the end of this tutorial on merge sort. Keep practicing, keep learning, and thank you for watching.